In 1679, after a fire tore through the wooden colonial town of Boston and burned it nearly to the ground, the colony banned the cheap timber shingles everyone had been using and ordered new buildings capped in fireproof clay tile instead. For the next century and a half, fired terracotta was the roofing material of choice in dense American cities, the exact same material that still covers most of southern Europe today. But then, almost overnight, America abandoned it. Now, if you go into almost any US suburb, you'll see a sea of asphalt shingles, a roof that gets torn off and thrown away every 20 years or so, sitting over attics that hit 130 degrees in July. Meanwhile, the clay tile it replaced can easily last up to 5 times longer and offer some remarkable cooling properties. Asphalt simply cannot match. So what does a clay roof actually do that asphalt can't? And why did the rest of the world keep it while America turned its back? Let's find out. Now, before we get to the clay, we need to understand what's actually happening above your head on a hot afternoon, because the roof is doing far more damage to your energy bill than most people realize. When the summer sun hits a roof, what happens to all that energy depends almost entirely on the surface it lands on. And a standard dark asphalt shingle is about the worst surface you could choose, because it reflects almost nothing. It soaks up 90 to 95% of everything the sun throws at it and turns it into heat. That heat has to go somewhere, and because a shingle is glued flat to the wooden deck underneath it, the only direction it can travel is down. On a hot day, the surface of that shingle can climb to 165 degrees Fahrenheit, and it drives that heat straight through the deck and into the attic, where the air can pass 130 degrees. That superheated attic sits directly on top of your ceiling, and in most American homes, the ductwork for the air conditioning runs right through it. So your cooling system is pumping cold air through metal pipes surrounded by 130-degree air, while the heat soaks down through the ceiling into the rooms below. So the real question for any roof is how much of that solar energy it can turn away before it ever becomes a problem. And it turns out a baked piece of clay is exceptionally good at it. A terracotta roof fights the heat in 3 separate ways at once, and together they explain why it makes an exceptionally good roofing material. The first is the simplest. The clay just doesn't absorb as much heat to begin with. A dark shingle reflects barely 5 to 10% of the sun, while natural unglazed terracotta reflects somewhere between 1/3 and 1/2 of it, bouncing a big slice of the near-infrared, the part of sunlight that carries the heat, straight back into the sky. And the clay is good at shedding whatever it does absorb. Engineers call that emissivity, and terracotta radiates roughly 90% of its absorbed heat back out to the air instead of holding onto it. But the really clever part is the shape. Look closely at a traditional clay roof, and you'll see the tiles don't lie flat, they curve, and they sit lifted off the deck on little wooden strips called battens. That leaves a continuous channel of air running underneath every tile, from the bottom edge of the roof all the way up to the peak, acting as a cooling engine. As a tile heats up, it warms the air in the channel beneath it, and warm air is lighter than cool air, so it rises, sliding up the slope and escaping through gaps at the ridge. As it leaves, it pulls cooler air in through gaps at the eaves down below, which heats up and rises in turn. The result is a slow, constant cycle of air flowing up the underside of your roof, carrying the heat away before it can reach the deck, a process known as above-sheathing ventilation. And the beautiful part is that it regulates itself. The hotter the day gets, the hotter the tiles get, and the bigger the temperature gap between the channel air and the outside air, which is exactly what drives the airflow. So on the most brutal afternoon of the summer, when a flat asphalt roof is suffering its worst, the clay roof's air channel is pulling hardest, moving more than twice the heat it would on a mild day. Then there's the thermal mass of the tile itself. Clay is thick and dense, which makes it slow to heat through. A thin shingle passes the sun's heat into your attic within minutes, but a heavy clay tile soaks that heat up and holds it, and by the time it works its way through to the inside, several hours have passed. The sun has gone down, the outside air has cooled, and the tile sheds that stored heat back out into the night instead of down into your bedroom. A surface that reflects more and holds less, an air channel that vents the rest, and a mass that delays whatever's left until nightfall, and you have a roof that cools the house simply by the way it's built. And there's plenty of lab tests and real-world studies to back all this theory up. At Oak Ridge National Laboratory, researchers ran clay tile roofs against standard asphalt shingles on identical test rigs. Around solar noon, the hottest part of the day, a high-profile clay tile roof cut the heat crossing the roof deck by up to 90%. The wood under the asphalt shingle hit 138 degrees, while the deck under a ventilated tile roof stayed more than 20 degrees cooler. The Florida Solar Energy Center also measured the impact in the place it matters most, the attic. A natural terracotta barrel tile roof ran its peak attic temperature about 40 degrees Fahrenheit, lower than a comparable asphalt roof, while also cutting the home's peak cooling demand by 13%. Like a lot of passive cooling techniques, the benefits are best where the climate is hot and dry. A clay tile roof over 1.25 inches of insulation cut cooling energy by 22% in Sacramento and 45% in a Chicago summer. And pairing that clay roof with ductwork, moved out of the attic and into the cooled part of the house, erased almost the entire cooling load, a 97% reduction. In dollars, retrofitting an older home with a cool tile system came out to around $200 a year off the utility bill. That's modest on its own, but there's also the superior lifespan to take into consideration here. A genuine kiln-fired clay roof has a working life of 50 to 100 years and beyond, and the proof is sitting on top of buildings right now. The clay tile roof on Harvard's Sever Hall was laid in 1893, and after more than 130 New England winters, it's still doing its job. An asphalt shingle roof, by contrast, gets stripped off and thrown in a landfill every 15 to 30 years. Run that out over a single century, and the math flips. The homeowner with asphalt replaces their roof 3 or 4 times over, and the running total climbs past what a single terracotta roof would have cost in the first place. So the clay roof has proven its value, but there is a small catch to it. You see, underneath the tiles sits a waterproof membrane, and that membrane isn't as tough as the clay. In a hot climate, the heat under the tiles cooks it brittle in 20 to 25 years, even while the tiles themselves stay in good condition. But the fix isn't a new roof. Roofers do what's called a lift and reset. They take the original tiles off, lay down a fresh membrane, and put the same tiles back for a fraction of a full replacement, buying another 20 or 30 years. The expensive part of the roof outlives the cheap part several times over. So, if clay cools better and lasts 3 times as long, why did America tear it off almost completely? Well, the answer to that comes down to a war, a building boom, and a set of incentives that quietly pointed the whole country at asphalt. After the Second World War, the United States had to build housing at a speed it had never attempted, and more than 40 million homes went up in the decades that followed. To move that fast, builders like William Levitt turned home construction into an assembly line, breaking it into simple, repeatable steps that didn't need skilled craftsmen. And churning out endless quantities of heavy clay tiles take both a lot of labor and time. It also needs a heavy frame to hold it up, because a clay roof weighs 4 to 5 times what an asphalt roof does. So the entire post-war house was redesigned around lightweight parts, thin engineered trusses, plywood sheathing, and more importantly, the asphalt shingle, which was cheap, light, and fast to apply. By 1960, asphalt had taken over American roofs, and the supply chains, building codes, and labor force all locked in around it. There's a second reason, and it's pure economics. Most American homes are built by developers who sell the house the moment it's finished. They pay for the roof, but they never pay the energy bills or replace it in 20 years, the future homeowner does. So, a developer has every reason to pick the cheapest roof that passes code, and no reason to pay extra for one that saves money over 50 years they won't be around for. While America went for the cheap and easy option, the rest of the world stayed with the traditional way of roofing. Across Europe, Latin America, and much of Asia, masonry and tile stayed the norm, and clay tile remained a mainstream trade with a deep bench of installers. In the United States, it shrank into a regional specialty, concentrated in Florida, California, and Texas, where the Spanish architectural tradition held on, while becoming scarce and expensive almost everywhere else. Now, clay offers some brilliant benefits, but that doesn't mean it's right for every house. There are some real limits worth understanding before you start tearing off your roof. The biggest is cold. Clay is porous, and it can drink up to 15% of its weight in water. In a northern climate, that absorbed water freezes, expands inside the tile, and cracks it apart over enough winters. That's why you see terracotta across the hot south and west, and far less of it in the freezing north. Though the very best high-density tiles, like the ones on that Harvard roof, are fired tightly enough to survive it. But then there's a risk of hail damage. Fired clay is brittle, and a big hailstone can shatter a tile, which makes the storm-battered plains of Texas and the central states a tough environment for it. And then there's the weight issue. If you want clay on an existing lightweight house, you'll likely need a structural engineer to sign off, and the framing reinforced first, which runs several $1,000s before a single tile goes up. But assuming your climate and structure permit it, then there are various ways you can utilize the benefit of the clay tile. If you're building new, design the frame for the weight from the start, and the structural problem disappears. Spec a roof rated for heavy tile, and insist on a proper ventilation channel using vertical and horizontal battens so the air gap runs clean from eave to ridge. And ensure you pay for a premium high-temperature underlayment instead of cheap organic felt, so the membrane doesn't cook itself brittle in 20 years. If you already own a tile roof that started leaking, then do not let anyone sell you a full tear-off. What you almost certainly need is that lift and reset. Get a team that specializes in tile resets, not general shingle labor, because a careless crew breaks tiles by the dozen handling them. And if you've got an ordinary lightweight house that can't take the weight of real clay, you're not shut out. You just go synthetic. Stone-coated metal panels and engineered composite tiles copy the barrel shape and, crucially, the lifted air channel at a fraction of the weight. Oak Ridge found that dark stone-coated metal with a proper air gap cut heat through the deck by 30% versus nailed-down shingles, matching real clay's thermal trick, while weighing barely more than the asphalt it replaces. The composites are nearly shatterproof too, which solves the hail problem clay can't. Whichever path you take, hold on to the one rule that makes all of it work. It isn't the clay that cools your house, it's the gap of air beneath it. Protect the airflow and keep the vents clear, and a roof will quietly cool your home for 100 years. Choke it off, and you've just bought a very expensive, very heavy, ordinary roof. Terracotta never actually went away. It just got crowded out of one country by a building boom that valued speed and low cost over longevity. But as summers get hotter and homeowners start hunting for cooling that doesn't show up on the electric bill every month, the oldest roof we have is turning up on American houses again, in clay, and in the lightweight materials that mimic it. If you found this useful and want more overlooked, low-cost ways to cool a home, subscribing is the best way to make sure the next one finds you. And if you want to learn how to properly utilize your ceiling fan to keep you cool this summer, make sure to take a watch of this video next.